Okay, today is the day where I do an extremely complex repair and I change the fuse in this power supply of mine. Why am I making a video about changing a fuse? A, because my brain has gone to jelly and I haven't managed to think of much else to do. I've got three power supply projects to do at the moment. This one, I have my other microcontroller controlled one, and obviously the high current heavy duty one to work on. That's one reason that I've got these three to work on, and the other reason is I've just been meaning to do this, and it's one of those things I should have got round to doing a long time ago, because not only am I going to change the fuse, I'm probably going to relocate it. So at the moment, here we are opening the case. This is a lovely little metal box picked up off eBay for a very reasonable price, and assuming I've undone all the screws, yes, as you can see, the back panel has nothing but a main socket with a built-in fuse. There we are. What you actually have in here is you actually have an analog power supply, a good old linear toroid transformer running into a regulator board, which then runs into just a cheap and cheerful buck boost converter. This one is, as I say, you couldn't have got much cheaper or much cheerfuler if you tried. I think it was about £4 from eBay. And all I've done is basically taken the 13.8 volt output from this linear supply and taking it to the input of here. Now, this is the fuse that's blown, and this is the output 8 amp fuse, and I'm pretty sure it's this one that's blown. So yeah, that might be the reason it's blown. As you see, it's completely charred away from the glass. So let's see if we can close up on that. Please focus. Shall I do an AVE, or shall I just push the button and see if we can get a focus in the middle? Are you gonna? No, you're not. You're just gonna be a pain in the bum, aren't you? So yeah, this poor fuse has decided to leave this earth of its own free will. That and vast amounts of current, and so it's time to change it, basically. And so that goes in the bin, because I'm not going to throw a good glass fuse somewhere else. And when I said I wanted to modify this, because I have to keep taking this apart to change that fuse whenever I cock up and set this thing to do something stupid or short out the outputs when I shouldn't do, instead of having the fuse here, what I'm going to do is I'm going to put a fuse on the front panel. Now, that will mean me drilling a hole. It's only 20 past midnight, so I think I can get away with that. I'm going to get my do not buy another one of these drills drill. Well, the fact that I've got 6.3 amp ones there is good enough. Let's just have a look and see what these ones actually are rated at, if I can read them. 10 amp at 250 volts, and I've got lots of them. So it's going to be a 20mm fuse holder. So what we've got to do is we've got to drill a hole that will take this fuse holder. Now, strictly speaking, I should drill an oval hole. In practice, I'm not going to, because I don't have anything that will drill an oval hole. and I can't be bothered to start filing the hole as an oval. So what I'm going to do, I'm going to get the good old-fashioned, I say old-fashioned, but this is modern high-tech electronic measuring equipment, about £4. I think you can even get them in Poundland now. They're not that good. Pair of calipers, go onto the threads, and it tells me it needs 12.85 mil. Possibly have a look in the box of Chinesian bits. We go with the smallest one. It only has to start the hole off after all. Right, so let's make it look pretty and get the measuring stick. Right, to the base of there is 36, so half of 36 is 18. So let's put it there. Let's get a pencil stick. Just make sure that that's reasonably straight. 18. Yeah, that looks about right. And then, what's the gap that I've got? 30. So if we go 15, that should give us the clearance of having that in the middle without interfering with that or any of the other controls. So there we go. Let's see if I can there we go, 1/2 inch hole. And just to make sure that there's no crap inside the power supply, let's give it a good shake, because we can. And sweep the swarf off, and your metal teacher will have told you never ever to do that. Don't put your hands in the swarf, boy, you'll get metal splinters. But you do, and what do? You get metal splinters, and you think, oh shit, there's something stuck in my finger. Welcome to my world. Right, okay, so we've got a reasonable hole. There is a bit of a burr on the back side there. I could, if I wanted to, I could remove the panel and actually just give it a quick burst from the other side. But what I'm going to do is I'm just going to use the tool, tilt it on its face, and just scrape the burr off by hand, like that. And yeah, it's not quite a perfect deburring, but that's why we have metal files. That's why we have needle files. All that's a screwdriver. Just moving the microphone. Which drawer is it? That's flat file. That's short. There we go. A little round file, and I can just again, and hopefully that will have just enlarged it the right amount to take the fuse holder, and we can put the nut on the back like so. What I am going to do is I'm going to put the two terminals to the top so that I can see them, and if I can get in with the little nut with the little adjustable, I'm going to tighten it up with that. There we go, and that's in solid, so that's not going to move anywhere. So the next thing to do is to find a couple of pieces of larger diameter wire, and if I look down to the piles of mains cable and the like, I must have something kicking around that's larger than average. That I don't mind using up for that. Yeah, that will do. It's nothing special. We're not going to be carrying large currents. Some people would say 8 amps, that's a horrendous current. Well, you know. As I was rudely interrupted by the camera saying, "Ah, you've recorded too much waffle." There's the other one soldered on there. And that now has repaired this particular supply. As you see, if I want to, I can replace the original fuse, and that will then return it to its former glory, as it were. I'm trying to see if there's a voltage adjustment on the board. I don't think there is. I'm not sure. It's been a long time since I've seen the inside of this power supply when I built it. I think this one was a fixed 13.8 volt supply, normally rated at between 5 and 7 amps for mobile PMR radio use. And all I did was add the variable voltage board, if I can learn to talk again, to the front end, and put it in so that I could make sure that everything was variable, and it boosted up as well. Well, it bucked up and bucked up, boosted down, buck down, boost up, whichever way it works. I can't remember now. Brain not working because it's now 10 to 1 in the morning. And yeah, there you go. A nice, simple, straightforward toroidal power supply. God, I'll learn to talk one of these days. In a metal box. Reason for using a metal box, so that the aluminium heatsink can actually have some cooling, and if you remember the top of the box, it has an air vent on the top as well to allow it to cool down a bit, and just generally for its own good, really. So what we've done now is we've done that. Let us get a 10 amp glass fuse from my box, or didn't I bother getting one? Yeah, there we go. Let's move that, put that away into there, close that. Ten amp 20mm fuse into the holder, into the front of the power supply, and there we have it. All I've got to do now is power it up and make sure it still works. That'll That'd be a good thing, wouldn't it? Let's put it on the bench. Where's the socket? There's the socket. Plug up. Okay. I'll get the motor seat trapped, and there we have the variable voltage power supply. It's not bad, does its job. Thanks very much for watching, and hope it was of interest. Bye bye now.